Today we'll be covering ratio and proportion, going through the work solutions for the worksheet. The first question tackles direct proportionality. So that's just a standard definition of proportionality. Y is equal to k root x. You plug in the numbers that are given. 75 is equal to k root 100, which in this case 75 is equal to 10k, obviously root 110. This gives us the value of k to be equal to 7.5, 75 over 10. And that's the formula linking x and y, which was initially defined as y is equal to k root x. It's just y is equal to 7.5 root x, seeing as we've actually found what k is. So y is equal to 7.5 root x. So now, inverse proportionality. Inverse proportionality is just defined as y is equal to k over, or k over something. In this case, it's x squared. That's just because it's proportional to k, is k times 1 over whatever your thing is, and that just leads to k over. That's just the definition of inverse proportionality. So again, we just plug in the numbers. Y equals 3, k we don't know, and obviously x is 144, 12 squared. That gives us a value of k, which is just 144 times 3, which is 432. So therefore, k is equal to 432. So now, using the fact, show that y is 27. So the show part indicates that you can't use this fact. You have to show it using the data you have available. So the data you have available is x equal to 4, and k is equal to 432. 432. So just using this fact, we know that, 4 squared is obviously 16. So we just do 432 over 16. And you do the calculation, that gives you 27. So we've proved that this works, and the relationship is fine. No problems. This is just more of a word problem and making sure you don't get confused in all the wording. So we start with a simple declaration. If we assume the weight of each cake is x, 18x is equal to 130. And from this we can deduce that the amount of cakes there are, or I guess the mass per cake, x, is equal to 7.2 recurring, or at least 7.2 a few times, which you can just store in a calculator for now. So 7.2. And now we have to figure out the amount of calories per gram. So I guess there are really two options here. Is it 329 over 100, or is it the other way around, 100 over 329? Give that a ponder. If you thought it was the former, you would be correct. It's indeed 3.29. I guess calories per gram. If there are 7.2 grams and 3.2 calories per gram, would indicate that just multiplying the two together should give the desired answer. So 3.29 times 7.2 per gram ends up giving you, if you do that calculation, that gives you 23.76 and a few other digits. So I think 3 significant figures is probably fine here. So 23.8 is probably accurate. So we'll go with 23.8 calories. So continuing with this, we'll be going on a bit of a harder problem this time. So to start out this problem, relatively simple as before. So V is equal to K over P. P is pressure, K, and V is obviously the volume. And I feel like since what we're looking for here is by what percentage will the pressure of the gas increase, it might be worth just changing the problem to just work around P. If we change this problem, we end up just getting P is equal to K over V. So we just want to see as V changes what happens to P. So to solve this, we kind of have to think about what changes with V. So really, a volume increase of 25%. What does that mean? Does that mean we have 0.25 V? Does that mean we have 1.25 V? Does that just mean we have, I don't know, what is the way to classify this and any other options? So just have a think about what that entails. So if you thought it's 1.25 V, it'd be correct. So a 5% increase just means that take whatever you have, in this case V, take 25% of it, so over 4, and add it on to what you already have, plus V. percentage is giving you 1.25v. That's kind of the definition of it. So we just want to see as v changes from v to 1.25v, what happens to p. So to do that, we can kind of think about what this means right now. So initially, we have p is equal to k times 1 over v. No problem. However, when we change the problem statement, what we're now asking, or we're now looking for, the statement is p is equal to k. K stays constant, so we don't actually care too much about k. K times, again, 1 over v. But in this case, it's 1.25v. So the way to really think about this is you have 1.25v, which is just the same as 1 over 1.25 times 1 over v. Obviously, 1 over 1.25v is just the same as 1 over 1.25 times 1 over v. These would multiply to be just 1, and this would be 1.25v. So now we've basically just added another multiplication to it. Usually it's 1 over v, that's fine. In this case, we've added 1 over 1.25. So that means p is usually just this part. This part is usually what defines p. However, now we've added a new variable into this, 1 over 1.25. And this is by what p changes by. That's what we have to pay attention to. So if we actually calculate what is 1 over 1.25, 1 over 1.25 is equal to 0.8. So what this means is, by not changing v is just v, then we have some value p. And if we're looking for p2, the new p, once the volume is changed, well, p2 is the same as p, except it's multiplied by this, 1 over 1.25. And this value is equal to 0.8. So what that really means is that p2 is just equal to p times 0.8. That's the change. So if it's times 0.8, that means that it's 0.8 or 4/5 what it used to be. So it's actually smaller because it's a fraction of what it used to be. Even if you think about it in English terms, a fraction of something is smaller. So 0.8, in terms of we're looking for the percentage increase or decrease in this case. So volume increase by 25, it's actually 0.8 whatever it used to be before, which just means an 80%. It's 80% of what it used to be. And obviously 100 minus 80 is equal to 20, which just means we have a 20% pressure decrease, so to say, as the volume is increased by 25%. So no, it's not just 25. You have to consider the relationship with 1 over 1.25. So 20% is the decrease. So the real thing to consider for this question is, what are you taking the percentages of? So if you think in terms of this question, first we'd actually be calculating the percentage. What is the percentage increase from 2001 to 2011? It's an increase of 60,000 people. The percentage is just that over what it started with, which is 420,000. And obviously if we do that, we get, I think, a seventh, which is the same as approximately 14%, so that 14 point something percent. That's just to give us a general idea. Now, if we think about the percentages for the next one, what are we taking the percentage of this time? 480, 540, maybe even 420 from what it started with. From our jump from 2011 to 2021, what are we doing? So obviously the increase was 60,000. It's told us that. What are we taking it of? Yeah, 480,000, if that's what you thought, correct? And that gives us instead a fraction of 1/8, which is about 12.5%. So while the increase was the same in reference to the population at the time, which was obviously bigger in 2011, 480 versus 420, the population change in terms of percentage is obviously going to be different. So therefore, no, his claim that it will increase by the same percentage was untrue. Same amount, but not the same percentage. So this was false. And that's our working for. So this question is actually quite challenging. So I guess we'll approach it from the beginning. So I think the best way to start would be to devise an equation where we take time into account of how much money they accumulate, where t will be the amount of weeks. So if t is equal to 1, that's 1 week, so on and so on. So Theo starts with 18, so we can just denote Theo's equation as 18 plus 4.5t. Because obviously he's 4.5 every week, and the same for James. Except, what do you think his equation will be? Give it a quick think, based on, maybe the previous equation. You're right, it would be 4t. That's what you thought, great. And basically, what we're trying to do here is understand what it means by this ratio. So 15 to 8, what does it mean really? Does it mean that of some amount, Theo has, let's say, I don't know, 1 over 15th? So if we denote the total amount of money they have after time t as x, does he have x over 15? Is in 1/15th of x? And does James have 1/8 x? So I guess same as x over 8 amount of the total money? What does it really mean? Does that mean that Theo has some amount x and James has 8 over 15 of that amount x, so 8x over 15? Maybe it means something a bit different. Maybe it means along the lines of Theo has 15 of a total of 15 plus 8 pieces, which in this case is just 15 over 23. And Theo has 8 over 23, in the same 8 over 15 over 23. Which do you think it is? Give it a quick think. And yeah, if you thought it's this idea, then yeah, you'd be correct. There's 15 pieces and 8 pieces, which are equal, which means there are 23 pieces in total, of which 15 Theo has and James has 8. That's basically our end goal. So I guess the best way to go about this would probably be to define some simultaneous equations. We have some value x and we have t, some unknowns, 2 unknowns, so simultaneous equation would be great. Start with the smaller one, James. So what we have is 4t is equal to 8 over 23x, where x is obviously the total amount they have at the time, their total savings. So if we do some cross multiplication, we basically get that 92t is equal to 8x. And from that, we can conclude that 11.5t is equal to x. And that gives us a direct conversion between x and t, which we can use. So now I guess we get on to Theo. So quickly think to yourselves, what exactly do I need to be writing here? So 18.5t is equal to what? What exactly should it be equal to? If you thought it was 15 over 23x, you'd be correct. That's obviously the amount that we're going for. So here the expansion is a little harder. So maybe do that and just expand. So yeah, basically this is 414 plus 4.5 times 23, which is 103.5 t, and that's equal to 15x. So now obviously we have a conversion to x to t, so now we can do what? Would it be better to substitute here or here? Really up to you. I think it's a lot easier since we just got x here rather than this. We've got 15, which is a bit cleaner than 103.5. We write that as 414 plus 103.5t is equal to 15 times 11.5, which is just 172.5 t. Obviously now we can figure out what t is. We can just do the subtraction. If you do it, you realize that you get 414 is equal to 69t. If you subtract this amount from here. And from that, you can pretty much calculate that t is equal to 6. If you do, obviously, 414 divided by 69, you just get 6. So that means after 6 weeks, they have money that falls in the proportion or the ratio that they describe. So the answer would be after 6 weeks. Now we're getting onto a ratio and proportion question that involves considering areas and volume of shapes. So what we know is that the volume of x is equal to 64 and the volume of y is equal to 343. So we kind of have to think about the relationship between these two. These two are volumes, but there's a variety of things we can do with this. Have a pause and think about what you think would be the best thing to do. Would it be to just take the ratio of these two as it is right now and apply that to the surface area? Would you maybe need to square these, square root these, cube root these? What do you think is the best approach to begin this question? If you thought to cube root both sides, you'd be correct. And that basically gives you a ratio of 4 to 7. Divided by 4, and this obviously 7. And then now, when you think about what the relationship means, we've cube rooted a volume, which gives us the kind of scale factor that we need to work with in terms of the lengths. 4 to 7, that's what we're working with. So now we need to consider surface area. Do we just use this ratio to go ahead with that? Do we square it, cube root, square root? What is the relationship we need to work with? If you considered squaring both sides, you'd be correct. 16 to 49 is, so if this is a length of sides, then this would just be the volume instead. This is what we're considering. Not the volume, the surface area. The area is in the square, the two-dimensional area. So this is the area. So this is the ratio of the sides. So what we know is that the surface area of x is 176. These aren't any real numbers. They're more of a relationship between one and the other. Think about what would be the best idea to go through next. Would it be maybe to take 16 over 49, multiply by this, add them together, and take the fraction and multiply 176? Maybe just to take 49 over this. If you thought it was to take 49 over 16, you'd be correct. And you'd multiply that by 176. The reason you're doing this is because this is a relationship between the two, and this is the value that you know. And this would give you the value of the second one, which is 539. As in this case, centimeters squared, to specify this the surface area of y. You might be thinking on a quick note why I cube rooted it here and in square root. If you want to go from if you're thinking, well, I started off with a cube, like x to the 3, why I can't just go, square root that to get to the square that we're talking about. But it doesn't really work like that. If we were to take x cubed and then square root all of that, that would in reality not really give us the square that we're looking for. For that you'd need it to be the power of a 4. But yeah, that's overall how you tackle this kind of question. Consider the relationship between percentages and changes. So first thing is important to think about what a percentage decrease by 40% actually means. Does it mean if you have some value x that it becomes 1.14x? Is it maybe something along the lines of x over 1.14? Maybe something even more outlandish, such as 1 minus 0.14 times x, which is just 0.86x. Whichever of these you think it is, give it a quick think. If you thought it was 0.86x, you would be correct. 0.86x, the reason why is because to consider what actually is happening. You have 100% of something, and you decrease it by 14%, which means you're just left with 86%, which you can just represent as 0.86 in decimal terms. So 0.86 is kind of how we relate. So 1 minus the percentage decrease, or 100 minus that percentage decrease, obviously, and then divided by 100 or 1,000 to get the relevant fraction that you're looking for. In this case, 0.86. So, how to relate this? We start off with this value, 101,325. So yeah, we go up 1 kilometer, and it would make sense if we multiply this by 0.86. But what does that really mean? Once we go more kilometers up, what do we actually have to do? Would it be something along the lines of this? Maybe we introduce the power term to the 4. Or would it be something along the lines of maybe something along these lines, 86 times 4. Obviously we're going 4 meters, 12 kilometers. Would it be the power multiplication? If that was the power, you'd be correct. What this really means is 101,325 times 0.86, and then again times 0.86, and so on, so on, so on. However many times the power percentage is what we're doing. We go up 1 kilometer, 0.86. Whatever that value is, we multiply that by 0.86, so on. The multiplication, what that really does is you're just multiplying this by just one number, which is just 0.86 plus 0.86, so on, however many times you're multiplying it by. In this case, you're just adding it that many times. So what we're actually looking for is the power symbol. And that's basically the crux of the problem, identifying that 0.6 is the percentage you're looking for, and that you'd be multiplying to the power of 4. Now that's left is to actually just do this calculation. If you type these numbers into your calculator, all you really get is quite a big number, 55425.601 ... Now we need to worry about the significant figures. So what it tells us here is it's two significant figures. that means is starting from the left, if it's all zeros, then you'd ignore the zeros until you get a number. But in this case, we start off with a number. So we have 5. So what we're looking for is two significant figures. That means we go first number, second number, and we do a cutoff. Now it says that actually 4 is smaller than 5, so the next number doesn't change. So we leave it as 5, and the rest just goes zeros. That's what we have, 55,000 pascals, or it's written here, Pascal.